Hello, so this is Lillian Zhao from Cover of Java, and I wanted to make a quick recap video going over the contents of our first week, and we decided this would be better since this will preserve the privacy of the kids who are taking the class, and also allow anyone else who isn't able to make the classes opportunity to learn the same things. So, let's get started. I might be skipping over some stuff because it's not content per se versus just like fun activities to do in class and keep kids engaged. So I'll skip over some of that. But the slideshow will always be linked, so if you want, you can go and do that stuff yourself, but just by finding it. So let's get started. So here is the overview of what we're going to be learning this week, or I guess this video. We'll be basically skipping over a lot of the welcome stuff and icebreakers. We'll be learning how to install Eclipse or set up a programming thing, what programming software really is, and we'll also be learning basic print statements, hello world, simple project, and also what are variables. So yeah, let's get started. First of all, welcome. I'm going to skip over some of this stuff just because um, this is mostly based in actual classwork, and we're going to skip it. But this is actually all really interesting, and if you guys want to look at it later, you can. Okay, so here's where we actually start. What is Java? So Java is a general-purpose programming language that is class-based, object-oriented, and designed to have as few implementation dependency as possible. It is intended to let application developers write once, run anywhere. So essentially, when we write code, our base purpose is to communicate with the computer, right? So we want to create some sort of language, I guess you can think of. Most coding languages, like the name suggests, they're just languages, and the purpose is to communicate with the computer. However, because they're computers and not humans, they communicate a lot different than how we normally communicate. So we need to have certain like standards and conventions for communicating with computers. And to do this, we have coding languages. So there's a lot of different coding languages. You can see in this chart, there's all the way over here is just ones and zeros, like bits, which you might have heard like computers communicate in ones and zeros, which is like not entirely untrue. On the very base level, they do, but these days it's a lot less that way. And as you can see, Java specifically, which we're learning, is a high-level language. And this essentially means that it's closer to natural language and what humans, I guess, normally speak, than something else like binary, which is the very low bits. And a lot of people, coding still has to follow conventions, obviously, but it's a lot more keywords. There's a lot more keywords and conventions to make it easier for us humans to write, and then like bits, which is not as easy for us to understand, obviously. Okay, so on to programming software. These are the basics, and yeah. So programming software is what you use to write code. However, there's a lot of different types of programming software. I think we'll have examples in the next slide. But on we have like Visual Studio. You can use PyCharm for any Python. Eclipse is the main one we use for writing Java, I think. People usually use IntelliJ and Replit for our collaboration stuff. So yeah. But on basic level, all programming software has three main features. This is debatable. But yeah, three main features, let's say. So they have a text editor, which is what you use to write code. So whenever you see someone writing code, like typing actually, that's the text editor part. And text editors can be as simple as Google Doc or Notepad, but usually programming software will make it easier for you to write by coloring the keywords or doing that type of thing where you can hover over things and you can see other references, for example, variables, where if you highlight it, you can see other instances where the variable is referenced, which is really helpful when writing code. And text editors try to make it easier for you to write code by doing these types of things. Okay, so next, compiler. So this is what actually turns what you wrote, your code, into language a computer can understand. And a lot of this happens in the background, and there's actually a lot of like both hardware and like software stuff that goes into it. So I won't get too deep into it, but there's like a whole world if you want to explore that. So that's pretty interesting, I guess, if you want to learn about that. Finally, there's the debugger. So this isn't really a specific, I would say, aspect of every programming software because you don't really need it. But I realized that how good a debugger is varies a lot from programming software to like programming software. For example, like Replit, the debugging software isn't that good. You can't add stop points. You can't do step by steps like that type of thing, which you can do in Eclipse. It basically just returns a line in the whenever it gives you output that just says like, oh, there's a problem on this line, or not very descriptive. And yeah, that's why the more heavy coding you want to do, the more you want to go to an actual application like IntelliJ or Eclipse because they allow you to do more detailed debugging, which when you're writing big programs, which reference multiple things and like are very complicated, a good debugger will go a long way to help you fixing your code once you write it. Okay, so yeah, like we said, there are many different programming softwares. Eclipse is, I think, the main one that at least I use, but others also include Replit, IntelliJ, Visual Studio, etc. And we'll mainly be using Eclipse and Replit. Like I said before, they have different features. In my opinion, Eclipse is very useful when you're programming by yourself just because it's easier to debug, it runs things faster, and yeah, overall, I just like it more. Like, it's easier to type for me, it's easier to run, I just understand it more. And it has better, like, package management systems, like a project package, all that, classes, all that stuff. Versus Replit, which is very useful for collaborative programming. So, because you can work on code with multiple people at once, and it's also online and easier to set up than Eclipse. So a lot of people like to use it when they're starting out, which is completely understandable. And yeah, let's move on. So how to create your project in Replit. As you can see here, there's just some steps for how to create it. It's pretty simple. You have to make a Replit account, obviously, and Replit's just a website. It's repl.it, as you can see here. You just search online. It will definitely come up. You make a Replit account, you click new Replit, you select Java as a language, and it appears. Like, it's pretty easy. Whereas Eclipse, I feel like it's much more complicated. So you first need to open Eclipse, click a file, press new project, and yeah, this will automatically select the job wizard. Click next. Anyway, this is like a lot of documentation, and it's kind of hard to explain without going to examples, so let's just go next slide. So here you see that I have a project explorer where I have my projects I already have, and I also have this is a text editor portion, and then all up here, this stuff is the features. This is debugger, this is a bug, isn't that cool? Okay, sorry. These are things that help you debug too. So yeah, to create a new project, you first press file, then you click new, and then you see here it says project, right? So once you click project, it will have this wizard pop up, and if you just select Java project, it will be fine, it will just work. So click that, and then this is where you enter the name of the project, and you can type like, oh, project name 01 or whatever you want, really. There's usually a naming convention. I think like don't start with capital or don't start with a certain like certain numbers or something, but that's not that important when you're coding on like first learning how to code. So yeah, just name whatever you want. Java environment. This should all be fine. Like unless you have specific bugs, which honestly I'm not the expert on, so I might just search it online and find an answer. But yeah, you press finish, and now you have a project here. So it will create this folder, and if you want, you can create a package, which might be easier. At least that's like convention I do. But you don't have to really create a package. You can just right click after you open the project, which is here. It'll create a Java library and then src. And then, which is, I think, I don't say anything. Right click here and click new. And if you want to make a package, it's right here. It'll just ask you to name the package and then just click in the package, make a new class. Or if you don't want to make a package, you can just make a new class by clicking new class. Simple. And as for name, obviously, if you want to make it appear with this public static void main thing, which most people want when they're starting out the code, just because this is pretty this might be not as universally used once you start adding multiple classes to your program, but I think for Cup 1, all our programs are limited to one class. So yeah, I'll basically always click this little tick, and it will just automatically write a line of code for you, which you can skip over if you're writing it yourself. So yeah. That's how to make a project. So let's move on to a brief history of Hello World, and we're learning how to do print statements if you didn't know already. So first, a brief history. The test message, a test message, Hello World is a test message that was first mentioned in a 1978 book by Brian Kerningham, and and I don't know how to pronounce the name, but that's not that important. So this was written in C programming language, which, if you saw before, is not what it was one of the lower level languages, which means that it was less friendly for humans, simplifying it. And it became pretty popular as a check for if the programming software worked, because everyone was like writing new languages, and they wanted to check that on the very basic level the programming software at least worked. So that's what they did. I think it's mostly because it's kind of like cute, I think, adorable that you're asking the computer to say hello world. So I guess it caught on. That's what I think caught on anyway. And yeah, and this is like a thing people do now. Like whenever they write their first program, it's always hello world, and we want to carry that on by making you print hello world as your first program. So yeah, in Replit, it automatically prints this out. That's how universal it is when you create a new program. But in Eclipse, you just do it manually by typing the text below. And if you might be wondering, like, what these tags, like class main, public static void main, what string, brackets, arguments, what does that mean at all? We don't know what that means, right? But yeah, that's a little complicated and convoluted to explain right now. If you guys take Cup 2, maybe you'll understand. But yeah, basically right now, just write it and don't pay attention too much to it because you'll learn what it is in due time. Okay, so the print statement you see here is the system.out.println, print ln, parentheses, quotations, hello world, and then a semicolon. Yeah, so, oh, by the way, always remember to put a semicolon at every end of a statement in Eclipse, because that's like I think it's like almost a joke at this point that you forget your semicolons, but yeah, Java doesn't like when you forget your semicolons just because it needs to know when you end a line. Like the semicolon is how it tells. I think some people they have like this weird thing where they just write all their code on one line and it have semicolons because to Eclipse semicolons is how it recognizes different lines. So if you just write all your code on one line but add semicolons, Eclipse doesn't really know the difference, which is kind of funny I think. But also shows the difference between organization for computers and organization for humans. And even if you can do that, I don't think you should because whenever there's going to be a bug, it's going to be really hard to figure out what the bug is. So yeah. Okay, so here's an example of ASCII art to the extreme, I guess. So here's a project I made called Hello World, and I printed a coffee cup that says Hello World. You can see in the console. This is the what printed out. This is the output, and this is my code for writing it. And yeah, so you guys already know how to do a print statement. I don't know if I emphasized it. It's just system.out.println parentheses and quotations, and then you can type whatever you want in between. And essentially, yeah, it just prints what's here. And I just did this manually, and I think it looks okay. It's not that bad. It's a coffee cup. You guys couldn't tell. It says Hello World. Yeah, so I just used a bunch of print statements, which was pretty easy. I think you guys can do it. And um, this was actually one of our projects to give you guys, I guess, some time to make your own ASCII art. And yeah, so if you guys want, you can try making your own ASCII art. You can be as creative as you want. I think there's even websites that generate ASCII art for you, though I think it's a little tedious to enter the ASCII art into a bunch of print statements, but I don't know, maybe it's fun. I think when I first started, I really liked doing it, so I would do a lot of creative stuff with print statements. It was pretty basic code, but I really liked it, so yeah. Okay, so let's move on to variables. And variables are kind of the next step in Java. So in coding, sometimes we want to have values that we assign to things and then use that value over and over again. So we need to create something called a variable to store that data in a value because we want the program to remember it. For example, if you're trying to count like the number of times that I don't know, you go through a line, or I guess let's just say that to get a coffee, number of times that customers get coffees in a line. And Sorry, this example isn't very good. Let me try one more, okay? So let's say we want to count the number of cookies in the cookie box, okay? And for you, that's kind of easy, right? You can just go 1 and then plus 1, so 2 plus 1, 3 plus 1, 4, etc., etc. But for a computer, it can't really remember the previous value unless you tell it to remember the previous value. So if your original value is 0 and you're saying plus 1, it'll go to 1. But then next time, if you don't create something to remember that the count is at 1, it will just go back to 0 and you'll have like a problem there. So to fix this, we create something called a variable which stores data or values that we want the program to remember. And the syntax for this is you put the variable type and then variable name and then equals the variable value and then of course semicolon. So these variables are assigned types. You might notice that I put the variable type in kind of, sorry, what is it called? Braces? Brackets? Sorry. Yeah, triangles. I put the variable type here. And so essentially in Java, you need to assign a type to the variable while you're making it, so that's easier for the computer. And this is basically for storage purposes, since different variables take up different amounts of storage space on the computer. But like I said for something else, that's a little convoluted for this course, so we're just gonna skip over that. Just know that when you make variables, you need to assign a variable type or object type, as you might learn later. So in this course will be using 4 main types of variables, and I think these are the most common for lower level programs or when you're first learning how to code. And it's int, double, boolean, and string. So as you guys might know from math class, a int is short for integers, which means that it's any um, integer. It's any number without decimal points. That includes negative numbers. So it could be 1, 100, 1000, or -1, -100, -1000, etc., etc. It's any whole number. It's any number without decimal points, essentially. So doubles are just numbers with decimal points. So it can be anything. Examples are 1.45, -4.2, or even pi. Those are all doubles variables. And next we have Boolean variables. And Boolean variables are essentially, if you think back to, uh, or yeah, let me just skip over. It's basically just true or false variables. So sometimes when you'll learn in the future you'll learn that we can have something called we have conditions for statements, such as if statements or while loops or even for loops. No, sorry, not for loops. Or kind of for loops. Well, anyway, we'll have conditions where it has to be true for something to happen. So Boolean variables are kind of the short version of that, where you can just assign a variable, a Boolean variable, a true or false value, and then that's just saying like if this is true, then this will happen. Sorry for explanation. I don't think Booleans are as common as other two, but they're more useful once you get to conditional statements. And finally, string variables. And string variables, these are basically words or sentences, and to indicate something's a string, you have to put it in quotations, such as hi or hello world. So as you saw before in our print statements, we put everything in the print statements in quotations because these are technically string values, which we can assign to a variable, which become a string variable. So to indicate it's a string, we have to put in quotations because that's how the computer recognizes it. And this can be double quotations or single quotations. I think I personally use double quotations, but single quotations are noticeably faster, so your own choice. And okay, so this is a page with examples of creating variables just because I don't think explaining it is really the most descriptive. You guys should see how it's actually used. So we have int example, double example, boolean example, and string example. As you can see, we have the variable type, which is this case is int. We have the variable name called variable1, and it's equal to 3. So in the future, if we want to reference this variable, we can just say variable1, and then the computer knows it's 3. And same for all of these, really. Let's just go look at string variables. String, as you can see, it's capital S, which does matter. These have to be lowercase, and this has to be capital. I mean, the first letter, obviously. You can name whatever you want for the variables, and these can be named whatever they want as a variable name. But it has to be one word. There can't be spaces in between. And yeah. There's also conventions for writing variable or writing names for things, which in this case I use like camel casing, which is essentially lowercase until the first letter of the next word, and that's uppercase. So as you can see, number of students and stuff like that. There's also people who use underscores, which are also fine. Just remember you can't have spaces in your variable name because your computer won't recognize it as a variable name. So yeah, let's move on. And remember the semicolons, of course. So here's the second basic project, I guess. You're going to be combining print statements and variables. So in this one, you can see we have the int number of students. We can have the int variable number of students is equal to 12. The double variable my weight is equal to 140.6, and the Boolean variable had breakfast equals true. So, and then we have the string variable my love is equal to Brianna Lynn. So as you can see here, once we print this, we can use print statements, which we learned before, to print out this this statement, and then we can use the addition sign to combine our text and our variables. And you can basically combine variables with strings just with the plus sign, and you can combine anything with plus signs in the print statements as well. And sorry, that was a little bad exclamation, but essentially, yeah, you just combine different things in print statements using pluses. And no, yeah. So as you can see here in our console output, it says in the Kava Java there are 12 students, and the number of students was a variable we added here, but it just printed like a normal string. And it says it is true. It is true that this morning I ate breakfast. After breakfast, my weight was 140.6. My dear friend Brianna is my love. So as you can see here, these are combined just because in the string here I didn't remember to add a space, so it printed like this. But yeah, lesson for you guys in the future. And you can see that we can just combine variables with strings. It's not that hard, and in the future you can get it to output more specific things after you do computations on the variables, which is pretty useful for creating basic programs. Which we'll learn about soon. So yeah, that's basically it for this class. We have a TED Ed hat riddle if you guys want to watch it. And also feel free to try printing out different statements with variables or just having more fun with your ASCII art and just get creative with it because you guys want you to learn how to enjoy coding because it really is pretty fun. So yeah, see you next time. Hope you enjoy this video and yes, goodbye. Oh, this is Cup of Java signing off.